Okay, here we have our vector question. This is usually the last question on an exam paper. It definitely is level 9, and if you're pushed for time, this is probably the last question you want to tackle. But if you're feeling good, then this is a really good question to pick up lots of marks on. Okay, so I'm going to do the diagram again, even though it's been drawn for me, because it simply helps me to think my way through the problem. Okay, make sure you mark the arrows of the direction, because if I'm going against the arrow, then obviously it becomes a negative vector. So if I'm going along with the arrow, it's plus 3a, and if I'm going against the arrow, it's minus 3a, isn't it? Right, we've been told that there's this point N on the line O to C, and it's in the same line as A, N, B. It's a straight line. So just do a little sort of dotted line, and then mark where N might be roughly. Now, the way we're going to approach this is that we're going to say, well, N is on the line A, N, B, but it's also on the straight line OC. So we can describe how to get from A to N in two different ways. So the first way to say is, well, if it's on the line AB, it's somewhere in the middle, isn't it? So we're going to say it's some fraction of the line A to B. So getting from A to N directly is like some fraction of the line A to B. And that's what I'm doing down here at the moment. Okay, some K is a fraction. Okay, and then I'm going to go from O to C as well. I can get to N that way. So the path O to C, well, that's like going, what? How do you get from O to C? 3a plus 4b, isn't it? Okay. So if I want to get from O to N, it's going to be some other fraction of O to C. I'll call that N. Okay. So there we have it. We've described two ways, but of course we need to know, we have to compare the same to the same. So I'm going to change my O to N to A to N. Okay, so how do I get from A to N? Well, I can go from A to O, can't I? And then I can go from O to N. That'll be one way I could do it. Yes. So I write down what A to O is, which is minus 3a. Yep. Plus O to N, which I've just written above. So I'll just write down what I've written above. Okay, so now I've described two different paths between A and N. But they must be the same, because they're starting from the same place and they're going to the same place, so they must be the same. So I can actually write down that my first way of getting from A to N is exactly the same as my second way of getting from A to N. And that's what I'm doing now, I'm equating them. Alright? And now I'm going to multiply those brackets out, and I'm going to compare the coefficients, the numbers or the letters in front of A, and the numbers and letters in front of B. So just multiplying out the brackets. If you underline your vectors, it's much better. You can see where the vector is immediately. Okay. Now, 6KB must be the same thing as 4MB, because that's the B direction vector. They must be the same because you're going from A to N. So I can cancel the B's and say that K, therefore, is equal to 4/6 of M. And of course 4/6 of M is the same thing as 2/3 of M, isn't it? So I've got my first equation, which I should label really, okay, with perhaps a star or an asterisk or something like that. Okay, now next we're going to compare what's in front of the A's. So minus 3k A must be the same as everything else that's got an A with it. Okay, so here we go. Minus 3ka is equal to minus 3a plus 3ma. And what I'm going to do now is I'm going to cancel what I can cancel. So I'm going to definitely cancel those A vectors, so the A's are all cancelled out. And I can also cancel a 3, can't I? 3, 3, and 3. If you cross out a 3, I'll definitely replace it with a 1, just to remind yourself it hasn't disappeared. And minus k is equal to minus 1 plus m. And let's just tidy that up, shall we, and make it look a bit nicer than that. So m is equal to 1 minus k. And now I've got two equations that tell me how k and m relate to each other. And that's enough to solve. So if I'm going to replace my k with what k is equal to, of course k is equal to 1 minus m from the second equation, I'm going to substitute that into the first equation, the first asterisk. So 1 minus m, don't worry, I shift the paper up in a second. 1 minus m is going to equal 2/3 of an m. Now what I'm going to do is I'm going to solve this for m. And hopefully I'm going to shove the page up in a second. Don't think I forgot to do that. I hope I didn't. So 1's going to, yeah, there we go. 1 is equal to 5/3 m, and so if I divide both sides by 5/3, that 1m is equal to 3/5. And that using my second equation, I can say that k is also equal to 2/5. Now let's just check the question. The question says find O to n simplified in A and B terms. So I want O to n, and fortunately for me, I've written down an expression for O to n. It's m lots of 3a plus 4b. So if that's the case, well, m we know, I'll just write down then, so m brackets, that's what we've proved earlier. Of course we know what m is now. It's 3/5 of 3a plus 4b. And that is it. We have shown what O to n is in terms of a and b. Okay, lovely. So these are usually quite valuable. Let's have a little look at the, have a little read through that. Do pause if you need to. Okay. And make sure you do find O to n and nothing else. Alright. And of course we'll look at the mark scheme. It's coming up now. I think. Yeah, it is. And of course we did the, well, which version did we do? It looks like we did the alternative there.